So in this video, I'm going to discuss the Dora and search problem which occurred in today's CODEFORCES challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. So this question states that this is the number of test cases. This is the n. This is the size of an array, and this is not basically an array. This is a permutation. And if you know what a permutation is, it is the elements from 1 to n in a jumbled fashion. Okay, that's what permutation means. So you have to find a sub array in which the extreme elements are neither the minimum or maximum of the subarray. Okay, like for this case, if we consider 1 and 4, that is the whole array as a subarray, the minimum is 1 and the maximum is 4, which are not the extreme elements, right? For this 2 and 6, 2 and 6, this part, the extreme elements are 3 and 5, but the minimum among this subarray is 2 and the maximum is 6, which is not at the extreme positions. So this is what basically the thing is about. And in this case, it is not possible to make such a subarray, so -1, and in this case also not possible, so -1. This is not possible, you know, because this not possible, this not possible, this not possible, this not possible, this not possible. So this is not possible. So let's say, like, you know that generally what a permutation is, it is like the basic permutation will be 1 2 3 dot 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 till n, right? Now what is the minimum? If I take the whole array, what should be the minimum be? 1. And what should the maximum be? N, right? So I won't be giving you the pseudocode, but I will be giving you the basic the basic thing, the basic algorithm that I am using. So minimum is initially 1 and maximum is initially n, right? So in this question, we are going to use the 2-pointer algorithm. So let's say 2 3 6 5 4 1. Okay, so let's write it down. 2 3 6 5 3 6 5 4 1. And what a 2-pointer is? There's one element which points to the first element and another element which points to the last element. Okay, and what is initially the minimum? Initially the minimum is 1. And what is the maximum? Maximum is n, right? Initially. Now if any of the extreme elements is either the minimum or the maximum, we have to exclude it. That is what the question tells us, right? So see, 2 and 1, so 1 is the minimum, right? So we have to exclude it. So we have, now j will be pointing to this, that is j minus minus. And since we are going to exclude 1, so the minimum will be shifted to 2, because 1 is excluded but from the whole array. So from the whole array other than 1, what is the minimum? Minimum is 2, right? That is minimum plus plus. Now it is 2. Now check if any of the extremes is either minimum or maximum. So 2 is minimum, right? So what we do, this I will be pointing over here, that is I plus plus. And since we are, the minimum is going to shift, since we are going to exclude 2, so the minimum was earlier 2, so now will be minimum will be plus plus. Okay, so now that is 3. Now see, for 3 and 4 is, so maximum was n, which meant 6. Okay, so now see, 1 2 3, now 3 is the minimum, right? And I is pointing to 3, so we can't do this. So the same thing will occur, that is I will be pointing to 6 and I plus plus, that is pointer shifts, and actually this is not going to be over here, the pointer shifts from here to here. Okay, the pointer shifts and minimum plus plus, that is now minimum, since we are going to exclude 3 also, so we have to replace this with 4. Now see, 4 and 6, right? Now 4 is the minimum, right? 4 is the minimum, notice this. So since 4 is the minimum, we have to shift it over here, that is j minus minus. But since we are like taking the minimum in case, so minimum plus plus. Okay, minimum plus plus, that is we are going to exclude 4 and make it 5. Now you can see that in this subarray 5 is the minimum and 6 is the maximum. Okay, since we have been using the minimum so many times, so let's check it out with the 6, okay, which is the maximum. So see, 6 is the maximum, which is I is pointing to 6. So now I will be pointing to 5 because this is the maximum and the extremes contains the maximum. So this will be pointing to 5, that is I plus plus But since this was maximum, we were handling the maximum, so maximum will get reduced because 6 is going to be excluded, so maximum will get reduced, so it becomes 5. Okay, 6 becomes 5. Now at this position where I and j collides, okay, if I and j collides, we have no solution, that is, it is going to be -1. Okay, to like make this a better one, to make you understand this better, so we'll be taking this 1 3 2 4 6 5 7. Okay, 1 3 2 4 6 5 7, and minimum is 1 and maximum is what? It is 7, right? So now I is pointing to this and j is pointing to this. This is minimum, so we will be going over here. I goes to here and j is initially over here. So now minimum is 1 plus 1, that is 2, right? Now see 3 and 7, any of them is minimum or maximum? Yes, 7 is maximum, right? So now j will be shifting over here and maximum gets reduced by 1, that is 6. Now see, j points 5 and I points 3, any of them is in extremes, that is 3 and 5, 2 and 6, all 4 are different, right? All 4 are different, so we can say that this thing is a subarray, the required subarray. So this is the basic thing. I won't be giving you the pseudocode, but if you know the 2-pointer concept, so I can tell you one thing, that how the pointer is going to shift. Okay, if ARR of I is equal to minimum, then I plus plus and minimum plus plus. Else if ARR of I is equal to maximum, then I plus plus and maximum minus minus. Else if ARR of I is equal to, ARR of j is equal to minimum, then j minus minus, because j moves towards the left, and maximum, whenever we are touching the maximum, we have to decrease it. And if we are touching the minimum, that is ARR of j is equal to minimum, then we have to j will be shifting towards the left no matter what, but since we are touching the minimum, so minimum gets incremented. Okay, and if none of the conditions satisfies, else we can just print I and j. Okay, remember one thing, I and j both are in 0 indexed form, so you can like increment 1 to it to make this a 1 index form. Okay, so whenever you're touching I and checking that it is either equal to maximum or minimum, since I moves from left to right, so you have to increment I. See, I plus plus, and over here also I plus plus. And if it is equal to, and whenever you're touching minimum, you have to increase the minimum, because that is going to be excluded, but the minimum gets incremented by 1. So see, minimum incremented by 1, and over here also minimum incremented by 1. So if you're touching the minimum, minimum plus plus, and if you're touching the maximum, maximum minus minus, and if you're touching the j, then j minus minus, because j comes towards the left. Okay, j moves like this and I moves like this. So this is the basic pattern. This is a 2-pointer approach. I think this one was a like, if you still don't understand it, you can like ping me up. I will provide both the links in the comment section. I will pin them. So yeah, that's it. Thank you.